So for linear transformation, we need two vector spaces defined on the same field. Let V and W be two vector spaces defined over the same field F, defined over same field F. So a mapping T with domain V and range W is called linear transformation if it holds the following property. Is called linear transformation if it holds the following two properties. The first property is that T image of two elements, let it be V1 and V2 will be the same as that of T image of V1 plus T image of V2, where V1 and V2 are elements of V, right? Where V1 and V2 are elements of V. And second property is that T image of alpha V1, T image of alpha V1 is alpha times T image of V1. Am I right? And what is alpha? Alpha is a member of field F, and V1 is any member of V. So let us see it using the diagram so that we can understand it, what is happening. So first of all, let us take V and W. Let us take V and W. So this is my V and this is my W. And T is a mapping from V to W. T is a mapping from V to W. If I take two elements, let it be V and W, or V1 and V2, better I will take V1 and V2, V1 and V2, then its image under mapping T is TV1, and image of V2 under mapping T is TV2, right? So image of V1 is TV1 and image of V2 is TV2. Am I right? Now, what is V? V is a vector space. V is a vector space. And you know, vector space satisfy closure with respect to addition. Vector space satisfy closure with respect to addition. So if when I add V1 and V2, I will get an element from the same space V. I will get an element in the same space V. Similarly, when I will add TV1 and TV2, I will get an element in the same space W, because W is a subspace. So I will get TV1 plus TV2 as an element of W. So now the first property says that the image of this element V1 plus V2 will be this much. So what is the image of V1 plus V2? Image of V1 plus V2 is TV1 plus V2, and it should be equal to this, right? Similarly, if we have V1, because V1 is closed with V is a vector space and it is closed with respect to scalar multiplication, then alpha V1 will be an element of V. And here you can see uh, TV1 is in W and W is a vector space. So alpha times TV1 will be an element of W. So second property says that if we take the image of this, so what is the image of this? Image of this is T of alpha V1, and this should be this element, right? So this should be equal to this. Is it clear?
Yes.
So let us take some examples in order to understand linear transformation. First of all, let us take the example of projection. Let us take an example of projection. Suppose T is a mapping from R square to R square, which is defined by T maps any element, say ordered pair xy, because it domain is R square, so ordered pair xy to ordered pair because codomain is R square, so that is x0, right? That is x0. So what I have done, see which point is going where. First of all, you have to look. First of all, see, I will draw x-axis and I will draw y-axis. Right? I will draw x-axis and y-axis. If I take a point xy, suppose this is the point xy, then if you apply t, then it is mapping it to the point x0. So it is mapping it to here, x0, right? It is the point x0. So what is this? This is projection of the point xy in x along x-axis. Projection on x-axis. It is the projection on x-axis. So we have to show that this mapping T is a linear transformation. So I will add so that T is a linear transformation. T is a linear transformation. Now, how we will show? In order to show that T is a linear transformation, I have to show two properties. First of all, Tx plus y should be equal to Tx plus Ty, and T of alpha x is equal to alpha times Tx. Alpha being a member of field. See, I am talking about R square. So what is my field? Field is R. You have to automatically understand that the field is R because Rn is a vector space over R. So you have to take this if it is not given. If it is not given, you have to take this. So first of all, we take two members x and y from the domain. Domain is my R square. Domain is my R square. So because x is a point of R square, so x can be written as the ordered doublet of reals. So I can write x1, x2, where x1, x2 are real numbers. Right? Similarly, y is a member of R square, so I can write y as the ordered doublet y1, y2, where each yi is a member of R. Okay, now let us see what we can do. Now, if you calculate T image of x plus y, then T image of x is what? X is x1, x2, plus y is what? Y is y1, y2, right? And if you add two members of R square, component-wise addition will be done, so that first component is added to first component and second component is added to second component. So what I will get? I will get T x1 plus y1 and here x2 plus y2. And what is the action of T? See, action of T is that it is making the second component 0. When T acts on any point xy, it makes the second component 0. So whatever second component is that will be 0. So I am getting the point x1 plus y1, and here I am second component being 0. Right? So now I will write it as the sum of two members of R square. So how I will write? I will write x1 0 plus y1 0, right? If you add component wise addition will be there. X1 is added to y1, it is giving this much, and 0 plus 0 is 0, it is giving you your second component. Now what is x1 0? See, t image of x1 x2 is this much, because what is the action of t? Action of t is that it is making the second component 0. So you will get this thing. Similarly, what is uh, t image of y1 y2? See, action of t is that it is making second component 0, and as such you will get this one. So now it is what? It is nothing but tx plus ty. x1 x2 is x, y1 y2 is y. Similarly, if you want to prove the next thing, suppose if you want to go for t of alpha x, right? So t image of alpha, alpha is a member of field which is R. So alpha being a member of R, so alpha x is x1 x2 because it is a member of R square, the vector space. So t alpha is getting multiplied to each component, so I'm getting alpha x1 alpha x2, and xn of t is that it is making second component 0, so alpha x1 0. I will get like this. So how we can write this as alpha times x1 0. I can write this as alpha times x1 0, right? So how we can write this? Alpha times t image of x1 x2, because xn of t is that it makes the second component 0, and now finally you will get it alpha times tx. So all the properties which are required to be a linear transformation is satisfied, and as such t is a linear transformation. As such t is a linear transformation. All right.
Yes.
Is there any doubt? Can I go for the next question? Am I audible?
Yes, sir. You can go to the next question.
Yes, sir.
Please, all of you, those who have no difficulty, please raise your hand. Those who have no difficulty, please raise your hand. Please raise your hand. Remaining students have difficulty. Am I right? Devans Mudgal. Devans Mudgal.
Yes, sir.
You have difficulty?
No, sir, I had raised my hand, sir. I think it got unraised again.
This is your second course, na, under my supervision.
Yes, sir.
Ayush Gupta, what is your difficulty? Ayush Gupta. Pratyush Patra. Danish Ansari. So these are all sleeping. See, it's your, if you will not do this course efficiently, then you will feel difficulty in entire life, because it's going to boost up your career. Whether you are going to study data science or other fields, It is required. Machine learning, everywhere it is required. Right? So please concentrate on the study. Now see, the second question which I am going to solve is define a mapping from T from R square to R square by, see, T maps ordered tuple xy to this number. See, e to the power x, e to the power y. Ordered pair of numbers defined by this. Determine whether T is a linear transformation. Question is, determine whether T is a linear transformation. Right? Determine whether T is a linear transformation. So how to solve this question? How to solve this type of question? First of all, see, because T is a linear transformation, so I can write T0 as T0 plus 0. And because T is a linear transformation, it is nothing but T0 plus T0. Right? T0 plus 0 is T0 plus T0. Why? Because T of x plus y is nothing but Tx plus Ty. Right? Using this property of linear transformation, I can write T0 plus 0 is equal to T0 plus T0. Now what I will do, I add both sides. I add both sides minus T0. I add both sides. So T0 minus T0 is 0. I'm writing 0. And here we have two T0s. If I add minus T0, then one T0 and T0 will cancel and you will have T0. Means what is the property? See, property here which we have to look is T. If T is a linear transformation, then T maps 0 element to 0 element. Right? See, I am saying if T is a linear transformation, then T maps 0 element to 0 element. Now I am going to give you one way of solving the problem. You know the statement, and you know when you construct truth table for A implies B, the truth table for the same is not B implies not A. Both are having same truth values. So these two statements are same. Just have a look at one word. If it will rain, I will go to Chennai. Right? If it will rain, I will go to Chennai. So the first statement is that if it will rain. Right? This is my A. Second statement is that I will go to Chennai. This is B. Okay? And suppose I take not of B, means I will not go to Chennai. I will not go to Chennai and it will rain. So not of this, if it will not rain. If it will not rain. So look at both statements. Is there any change? There is no change, right? So A implies B is the same as that of not B implies not A. See, this is your statement A, right? If T is a linear transformation, T0 equal to 0, this is your statement B. And here A is implying B. So not B means not this. T0 is not equal to 0 will imply not A. T is a linear transformation A. So T is not a linear transform is not A. So T is not a linear transformation. So T0 is not 0 implies T is not a linear transformation. So now you can see, if I substitute, if I will find and substitute x0 and y0. So this is the 0 element. So it is nothing but e to the power 0, e to the power 0, and it is 1, 1, which is not equal to 0, 0, not equal to 0, 0, and hence T is not a linear transformation. Okay, this way we can construct. Is there any problem in this? Is there any problem?
Sir, can you like repeat for this question? I didn't get.
Which statement you want to be repeated?
Like this blue one, like how like T0 is mapping to 0 and that one.
This statement you studied, A implies B and not B implies not A.
Yes, sir. Truth table is same. Yes, sir. I know.
See, it's a very simple. See, I'm just repeating. See, A implies B and not B implies not A. These are contrapositive statements, right? And these two statements are equivalent. They are same, right? If we say A implies B, the same thing we can express in other words, not B implies not A. For example, see, statement A I am making, I will, or you write, if it rains, if it rains. This is my first statement. Then this implies B. Then I will go to Chennai. I will go to Chennai. What it means? If it rains, then this implies that I will go to Chennai. This is my statement A. This is my statement B. Am I right? So I will go to Chennai is a statement B. So not B is just negative of that. So I will go to Chennai. So what is the negative of that? Not B. I will not go to Chennai. I will not go to Chennai implies not A. Implies not A. If it doesn't rain. If it doesn't rain. Right. So this is, look, both statements are same. Both statements are same. It is representing the same thing. It is representing the same thing. So in the same way, if T is a linear transformation, if T is a linear transformation, then this implies T0 equal to 0. If T is a linear transformation, then this implies T0 equal to 0. So this is your statement A, and this implies B. This is my statement B. So T0 equal to 0 is B. So what is negative of this? Negative of this is T0 is not equal to 0. This implies T is a linear transformation. What is negative of this? Negative of this is T is not a linear transformation. So if you find that T0 is not equal to 0, then T is not a linear transformation, right? So now you can see here how we have defined T. T takes ordered pair xy to an element which is defined by e to the power x, e to the power y, right? E to the power x, e to the power y. So first check which you can do is that you put x equal to 0, 0. So 0 element of R square is 0, 0. So if you put x0, y0, so here x0, y0. So as per the definition of T, it will map to this element, right? And this element is nothing but 1, 1. So T is mapping 0 element to non-zero element. So T0 is not equal to 0. So T is not a linear transformation. So T is not a linear transformation. Okay.
Yes, sir. Got
This
it.
is called contrapositive statement. This is called contrapositive statements. Okay.
Yes.
One way of solving or doing mathematics, sometimes you assume false and try to derive results. Sometimes you use contrapositive results. Sometimes you use induction. So there are different ways of solving problems, and you have to know each and every method, when to apply, where to apply. These things you will not find in books, right? So these are the things which we will get from experience. So you have to just master all these things. Next question is, give an example of a linear operator T. Give an example of a linear operator T from R square to R square, defined as uh, uh, T from R square to R square, or you write such that T square is 0, but T is not equal to 0. Can you guess how it can be? Can you guess how T square is 0 but T is not 0? Anyone? Anything in mind? We can solve this type of problem. Anything is coming?
Like for fraction one, it's
No. See how I am defining.
Complex
Right?
numbers, sir.
No.
So
How I am
complex
defining? See,
possibility,
suppose
sir.
T is a map from R square to R square, defined by, suppose T maps any element alpha beta to beta 0. See what is the action of T? Second coordinate comes in the place of first, and second coordinate becomes equal 0. Right? Second coordinates will become first, and second coordinate will become 0. So you can see here that T is not 0. If I say T11, then second coordinate, this will come in the first, or I write 1 2 better. So 2 comes in the first position and second coordinate 0. So T is not 0, right? T and 0 are, actually we say equivalent, right? Better word is equivalent. T is not equivalent to linear transformation 0. Okay. But what happens if I say T square of, say, any element, let it be alpha beta, T square of alpha beta. So I can write it as T of T alpha beta. T square I write T of T. So when T operates on alpha beta, I will get beta comes in the first position, second coordinate 0. And again, if you operate T, then this 0 will come in the first position, second coordinate 0. Therefore, T square is equivalent to 0. If you use word equivalent, it will sound better. Am I right?
yes.
Is this clear to all of you?
Yes, sir.
Yeah. So next I will jump onto the projection, but projection in Argand plane, right? I will go to projection, but projection in the Argand plane, and see how we can solve. See, is the mapping T from complex space to complex space defined by say T maps the point x plus iy to x only. X is nothing but x plus I0. Yeah, x plus I0, making the imaginary part 0, a linear transformation. A linear transformation. Right? Here answer is no. Here answer is no. Suppose you have two numbers Z1 and Z2 in domain C. So Z1 I can write as A plus IB and Z2 I can write as C plus ID. So what is TZ1 plus Z2? TZ1 plus Z2. So Z1 plus Z2, when you add Z1 and Z2, you will get A plus C plus I, B plus D. Am I right? So now you can see here that it is making imaginary part 0. So when T operates, it is making imaginary part 0. So you are going to get A plus C only, which is the real part. And now this is okay. T image of A plus IB. See, when I apply T to A plus IB, it is making imaginary part 0. You will get only A. Similarly, T image of C plus ID. So when T operates on C plus ID, it is making imaginary part 0. You will get C only, which is this. And now this is nothing but TZ1 plus TZ2. So first property is satisfied. But second property, we have a doubt. So I am giving one counter example. And what is my choice? What is my choice? Any pair of complex conjugate numbers can serve our purpose. Any pair of complex conjugate numbers can serve our purpose. Am I right? So let's see how it can be proved. So suppose I have to show that T of alpha Z, or here Z1 I have taken, so alpha Z1 should be equal to alpha times T Z1. For all alpha and for all Z1. For all alpha belongs to field, field is my C, and for all Z1 belongs to C. See here, Cn is a vector space over C, so C is a vector space over C. So field is this one. This is my field. You have to automatically understand this thing. You have to automatically understand this one. Now see, what I have to give one counter example, and one counter example is enough to discard the theory. So let us take alpha equal to 1 plus I, and Z1 I will take as 1 minus I. Complex conjugate numbers. So let us calculate the LHS. So this is T image of alpha Z1. Alpha is 1 plus I, Z1 is your 1 minus I. Right? So when I multiply 1 square minus I square, so 1 minus minus 1, 1 plus 1, 2. So it's giving you T image of 2. And 0 I will write for better understanding. So what is the action of T? Action of T is that it is making imaginary part 0. So I will get 2 here. I will get 2 here. And similarly, if you go to RHS, it is alpha times TZ1. Alpha is 1 plus I and TZ1 is 1 minus I. So what is the action of T? It is making the imaginary part 0. So only 1 I will get, and 1 multiplied by 1 plus I is nothing but 1 plus I. So you can see these two are not equal. Therefore, T times alpha Z1 is not equal to alpha times TZ1, and as such, T is not a linear transformation. As such, T is not a linear transformation. Okay.
Okay, sir.
Everyone fine?
Yes, sir.
Okay. Let's go to another question, and it will be, you just concentrate on this question, because this question is very much important. Let me check how much of you are attending. 40. Okay, I will go ahead. So now next question is very much important. See, let T from R square to R square be a linear transformation, such that T maps element 1 1 to 1 3. See, T maps an element 1 1 to 1 3. T maps element minus 1 1 to 3 1. Then your question is find TAB. Find T image of any point AB for any point AB belonging to R square. Right? This is your question. You have to find T image of AB in terms of A and B. So let's see how we can solve this question. First of all, what are the things which I know? We know 1 1 and we know minus 1 1. And see, 1 1 and minus 1 is a basis for R square. These are linearly independent and it can span any element of R square. So specifically it will span AB. Suppose I want to express AB as a linear combination of 1 1 and minus 1 1. Then what I have to find? I have to find X and Y, which when substituted here will provide you AB. Right? So X and Y you have to find. Either you solve the equation, you make the system of equations and solve, or you can do it with your experience. Right? Suppose you want to solve, because if you are not experienced, how you can solve? So let us see how, if you want to solve this one, how you can do. See, right side x into 1 x. So I'm getting xx plus minus y and that is equal to AB minus yy. And now if you add the first component, you have x minus y equal to A. If you add the second component, you have x plus y, so you have x plus y equal to A. You add 2, minus y plus y 0, so 2x equal to A. So you are getting x equal to A by 2. Right? If you add the both, how much you get? In the left hand side, you will get 2x. In the left hand side, you get 2x, and here, sorry, here you get 2a. So 2 getting cancelled, so x equal to a. Sorry, you get x equal to a. Right? And
Sir,
yes, please tell me.
X
so here
will be equal to A plus B, no, sir.
yes,
By 2.
1
second
minute.
X plus
Okay,
Y equal to
okay.
B, no.
Okay. A plus B. That's why I was in doubt. Okay, 1 minute. I'm making correction. So right side is B. So x plus y equal to b. Okay, you add. So x plus x is 2x equal to a plus b. So x equal to a plus b by 2. Okay. And now when you substitute this value in any of the equations, you can get y. Or otherwise, what you do, you subtract the 2. Now you subtract the 2. So it is minus, minus, minus. So x minus x cancel, minus y is minus 2y equal to a minus b. So y equal to b minus a by 2. So y also we are getting, right? So y also we are getting. So AB can be expressed as b minus x. X is a plus b by 2. Let us have a look. AB I can express as x is a plus b by 2 times 1 1 plus y is b minus a by 2 minus 1 1. right? So you first of all you express AB as a linear combination of 1 1 and minus 1 1. Now you apply T. Now you apply T, right? Now if you will apply T, then what will happen? See here, first of all plus sign is there, and you know T of x plus y is equal to Tx plus Ty, right? You know this thing. So T distributes over addition. So T a plus b by 2 1 1 plus T time b minus a by 2 minus 1 1. You are going to get this thing. And second property of linear transformation is that T of alpha x is alpha times Tx, means constants can be taken outside. So this constant will be taken outside, and similarly this constant will be taken outside. So you will get a plus b by 2 T image of 1 1 plus b minus a by 2, you get T image of minus 1. So now see, these two quantities are given in question. So 1 3 and 3 1. So you write a plus b by 2, you get T image of 1 1 is given as 1 3. See here, T image of 1 1 is 1 3 and this is 3 1. So I will write plus b minus a by 2 into, here it's 3 1. Fine, now I can get all the things easily. So first component is a plus b by 2 and 3 times b minus a by 2. You multiply, so a plus b by 2 plus a plus b by 2, or you write first as a component. So a plus b by 2 and 3 by 2 a plus b. And here you write 3 by 2 b minus a, and second component is b minus a by 2. So you add this plus this. So denominator is 2. You write a plus b plus 3b minus 3a. And here again you write denominator is 2. 3a plus 3b, 3a plus 3b minus, plus b minus a, plus b minus a. Let me check once more. A plus b, 3b minus 3a, right? So I'm getting this one, and here what I'm getting, 3a plus 3b, 3a plus 3b, b minus a. Now you can see 3b plus b, that is 4b minus minus 2a, minus 2a divided by 2, and here you have 3b plus 4b minus 4b plus 2a divided by 2. So what you will do, first of all, you take 2 common and cancel. So you have 2b minus a. Here you will have 2b plus a. And this is your expression. T of AB should be equal to this one. 2b minus a and 2b plus a. Okay? Is it all right? So in next class, we will solve some more problems based on this. Then we will go for matrix representation. And then again, we will come back and study dimension and dimension theorem and based problems. And then I will come back to similarity and other concepts. Thank you. Any question you can ask? You have any question?
No, sir. Thank you, sir.
Thank you.
Thank you, sir.
Thank you.